Welcome, everyone. Thank you for joining us tonight for virtual skywatching for the statewide star party. My name is Amy Sale. I'm an educator at Moorhead Planetarium and Science Center. I am in a very large room with the windows open, socially distanced from two other people. All of us are fully vaccinated, more than 2 weeks past our second dose. So I'm going to go ahead and take off my mask. And Moorhead Planetarium and Science Center is part of the University of North Carolina at Chapel Hill. We're located on campus. We also work throughout the state with various outreach initiatives, and we produce the annual North Carolina Science Festival. Part of the festival is an annual statewide star party made possible with support from NC Space Grant. This right here is one of many star party events happening today and tomorrow with the help of our partners across the state. And in this program, we'll be talking with experts and looking at telescope views of objects in the North Carolina sky. The program will officially last an hour. We'll go until 9 p.m. Eastern time. But if you would like to hang on longer, if you have more questions, want to see more things, we plan to stay logged on until 9:30 p.m. We are joined tonight by three special guests. I'd like to start by introducing Dr. Sheila Kannappan, who teaches Astronomy 101 and researches galaxies in the Department of Physics and Astronomy at UNC Chapel Hill. And Dr. Sheila, would you like to say hello?
Hi, everyone. I'm joining from Chapel Hill from my home, and I'm delighted to be here.
Thank you. Also joining us are two amateur astronomers, Mike Keefe and Doug Lively. They are both NASA JPL Solar System ambassadors, and they are both members of the Raleigh Astronomy Club. And Mike, could we start with you?
Yes, thank you. Hi, happy to be here. I am joining from my driveway in Apex, North Carolina.
Thank you, Mike. And Doug, tell us where you are.
Thank you, everybody, and welcome, folks. My name is Doug Lively, and as Amy said, I'm a NASA JPL Solar System ambassador, and I'm joining you guys home and driveway in North Carolina.
Great, thank you. And those of you who are in the Triangle area might know we are contending with some clouds. We do have a backup plan, so don't worry. We will show you amazing images, rain or clouds or clear skies. Also off camera, many feet away in this room, helping with technical aspects tonight are Eric McIntosh, who is program manager for the North Carolina Science Festival, and my fellow planetarium educator, Nick Eakes, is helping as well. Those of you who are watching on Zoom, there is live captioning. If you find that distracting, look for the button that says live transcript and you can hide the subtitles, but we have the captioning to help make this accessible. Some of you are watching this as a Zoom webinar. Others are watching via YouTube live stream. For those of you watching on Zoom, if you want to ask questions, please submit those using the Q&A feature on Zoom. If you are watching on YouTube, you can also ask questions. What you need to do is send an email to us at ncscifest@unc.edu. We'll get as many questions as we can while we're going along. We'll also save a few minutes at the end right before 9 o'clock to get questions as well. All right, and we will ask you questions too. So those of you who are watching on Zoom, get ready. A question is going to pop up on your screen. We would like to know where you are watching from right now. We're guessing many of you are in North Carolina, but maybe not everyone. Tell us where. If you're watching on Zoom, you have 4 options. Tell us if you're in Eastern North Carolina. Maybe you're in Central North Carolina, like all of us are, the presenters. Maybe you're in Western North Carolina, or maybe you're not in North Carolina at all. You're in some other state or maybe even some other country. So we'll give you a few more seconds to tell us where you're watching from. We're curious to know if you're seeing the same sky we are or not. Those of you to the east, your sun set a while ago. Those of you to the west, you may still have bright daylight. Those of you way west, it could be just afternoon for you right now. So we'll give you a few more seconds and then we'll find out where you are watching from. In a moment, I will be sharing with you some planetarium software. This gives us a chance for the sky to get a little bit darker, give our telescope folks more time to get set up. Oh, okay, I see we do have some people watching from outside of North Carolina, and it looks like most of you are in Central or Eastern North Carolina. Thank you so much for joining us. All right. So I am going to share my screen, and I'm going to be showing you a planetarium software program called Stellarium. And this is going to give you a preview of what we're going to be looking at through the telescopes tonight. So Stellarium is free software that you can download for your own computer or device if you would like. The website is stellarium.org. There's also a web-based version if you don't like to download things. And just to orient you really quickly, you'll see I'll use my arrow, my cursor to kind of move things around. I'm pointing out the grass or the ground. You'll see the sky. This is as it looks right now from Chapel Hill. It's not noticeably any different for the rest of the triangle area. And you'll also see the date and the time. It's a 24-hour clock, so 20 corresponds to 8 p.m. And this last part just tells us the time zone. You'll notice that the horizon looks like it's all curved. The horizon is where the sky meets the ground. That's because we have to show you a little bit of a distorted view so that we can show you as much of the sky as possible. So our view is looking south. You will not see these red letters when you walk outside. And we hope you will walk outside and look at the sky tonight, wherever you are. If you're facing south, east is to your left and west is to your right. And you don't see the N for north because it is behind you if you are facing south. It's still getting dark here in the triangle area. So you might just notice a few things. You might see a bright star. That's the brightest star in the night sky, Sirius. You might notice that the moon and Mars are up. I'm going to do a little planetarium magic here and keep us up just a little bit later. So I'm going to speed up time, and this will make the sky get darker. So if you look at the clock in the bottom right, you'll see that the time is ticking up faster. And there, Stellarium just popped on a label for the brightest star in the night sky, Sirius. And a few more stars are starting to come out. Looks like we have some interesting things there over in kind of the west-southwest. I'm going to keep us up till past 8:30 or so. And now I'm going to spin us around to the west. So we're turning. Let's go west. And I'd like to point out the moon right here. I'm not going to zoom in on it. I'm going to leave you in suspense. I will say that it is not full moon. It is not fully lit. You'll see when we get a view in just a moment, telescope view. And then you'll notice Mars here as well. The statewide star party this year, this is our 9th annual statewide star party. The theme this year is Moon and Mars, and it's partly because these objects are so prominent in the evening sky tonight and tomorrow night as well. So I hope that you will all go out and look for Mars in the real sky. The moon is going to grab your attention right away. Mars will look like it's above the moon tonight, but the moon moves from night to night and day to day. And planets do as well. So you can't use the moon as a marker for finding Mars because the moon is not always in this location. So tomorrow night, for example, make a prediction to yourself right now. What will the sky look like tomorrow night if I jump forward 24 hours? Let's find out. The moon is on the other side of Mars tomorrow night, and then the next night, and the next night, and the next night. And if you look closely, you might see that Mars is actually moving relative to these two stars. These two stars represent the tip, I'm gonna go back here, the tip of the horns of Taurus the bull. Let's see if I can highlight Taurus the bull for you. So I'm going to add some lines here. I don't know how you get a bull out of that, but I'll help you out a little bit. So there's Taurus the bull. And Mars is hanging out in that part of the sky right now, as is the moon, for that matter. Okay, so if you are wondering, how are you going to find Mars if Mars moves? Well, 3 planet finding tips. Number 1, planets tend to be pretty bright. Sometimes as bright as the bright stars in the sky, but not always. You'll notice, for example, Sirius and Capella are noticeably brighter than Mars, but it's pretty bright. So planets tend to be pretty bright. Also, you can remember that it goes twinkle, twinkle, little star. It's not twinkle, twinkle, little planet. So stars look like they're twinkling, shimmering, kind of dancing a little bit, going bright, dim, bright, dim, bright, dim. Planets usually look like they're shining steadily. So twinkle, twinkle, little star, not twinkle, twinkle, little planet. It's hard to tell that in Stellarium. You'll be able to notice in the real sky. Also, planets aren't found just anywhere in the sky. You're going to find them in or near a zodiac constellation. So that's why you're seeing Mars hanging out in the direction of Taurus right now. So it makes sense that Mars would be in this location. Okay, so I'm going to stop sharing my screen and let's check in with our astronomers here. And I'm wondering if Mike or Doug, what's the situation there with the sky?
All right, I think I'm
Yeah, we
live.
definitely have moon. Yeah, go ahead, man.
So Doug, if you've got it, I'll let you start.
Right. Sure, I'll go ahead and share my screen. All right, if you guys can see my monitor, I've got the crescent moon lazily floating along here in the night sky. If you can see my cursor, I'm going to circle. This is Mare Crisium.
And we are seeing you right now.
No problem.
Ah, here we go. I think we're about to see.
Here we go.
Oh, lovely.
Great. So we have the moon here, and it is moving a bit, and I'm going to give it a little shove back. And you'll see that little wobble there. But I'm going to circle. This is Mare Crisium right here. And here's Mare fecunditatis over here on the other side. And so that's about all we have that's illuminated in terms of the mare. And these mare are actually basaltic flows where there was a giant impact at one point in time in the moon's geologic past. And it was hit so hard that it broke open the crust and magma spewed out, forming these really dark basaltic plains. The round objects that you see right here, as I'm circling them with my mouse, these are commonly known as craters. I think many of you may be aware of that. And that's basically where you had a meteoric or a small asteroid impact the moon. Wasn't strong enough to break the crust, but it did leave an impact. So, and I don't know, Mike, you want to take it off with a few other things, or I can continue talking about the moon?
Yeah, no, absolutely. So
all right, I'm gonna stop my share then.
Yep.
Okay, and while y'all are working on that, we've got a question. I'm not sure if I understand the question, so I might ask the person to rephrase it, but it says, why does the moon look smaller than what it does before you zoom in? I'm not sure exactly what that means. If the person who wrote that question, if you want to phrase it a different way, feel free to type that in again.
Yeah, so while we're waiting for that, now if I can just get the control bar off, there we go. So I've got a wide field view of the moon, and I'm gonna go ahead and kind of zoom in. We can kind of just, so now I'm using the camera's native, and you can start to see this shimmering effect now as you're looking at it. And what we're seeing is light refracting through our atmosphere, causing the light waves to kind of almost look like we're staring through a glass of water, or maybe in that hot summer afternoon, you look down a road and you see that the pavement shimmering. That's basically what we're seeing here, are the effects of the light being refracted through our atmosphere.
Mike, can I jump in with a question, because this may be a little bit relevant to what you just said. We've got a question from Tim about why don't planets twinkle like stars do? Do you want to tackle that one? I'm happy to.
I will give you my best option or best answer, and that is that because we're so close to the planets, they don't appear to us as a single light source or a single point of light. So it's a little bit, in other words, the light that's coming through is a little bit wider, if you will. We're getting kind of a wider view. So they do refract, but because you're dealing with kind of a wider beam of light, it doesn't twinkle or you don't notice the movement as much. But I will let the experts answer that probably more appropriately.
I'll interject on that one as
That was great.
well. And that is that just as Mike said, for most stars, you have a much smaller beam of light. Now, for the much larger stars, you don't really notice that twinkling or scintillation that you see with the smaller stars. And this, again, as Mike said, smaller beam of light. And so what happens is it's more easily disrupted by our atmosphere. And so you see that shimmering or that twinkling occurring. So the much larger star, like for instance, Sirius really doesn't twinkle all that much. But you might see like a small star, like maybe a smaller or more dimmer light, like maybe Capella or something like that would twinkle. So that's but Mike's point there, it's really the smaller beam of light that gets disrupted by our atmosphere.
All right, I'm keeping an eye on the questions in the chat. We've got a number of questions about the moon. I'll pull out one of these. Why does the moon look like it's not shining when the sun is behind it? Anybody want to tackle that?
Yeah, so when the sun is behind the moon, it, in essence, the moon itself doesn't shine, it just reflects light. So in the case of the moon, when you're approaching what we call a new moon, you have, in essence, if you have the Earth, moon, and then the sun in that alignment, the sun is actually illuminating the other side of the moon, what we call the backside of the moon. So
Okay, I think we lost Mike there for a second.
So another way we could answer that question is to say that actually everything shines a little bit, but the moon is incredibly cold. So when the sun is not shining on the moon, it is minus 173 degrees Celsius. I'm not sure there's anywhere on Earth that's so cold. If so, I don't want to go there. But when you think about something so cold, it barely gives off any glow of its own light because it's so cold. And we as humans also glow just a little, but barely at all. Whereas the sun is nearly 6,000 degrees. So it glows brilliantly. And that's why the moon doesn't seem to glow at all.
Thank you. I'll ask one more question that came in by email about the moon, and then we'll probably be ready to switch to Mars if you all are up for that. I'll wait to hear from our astronomers if that's possible. The question that has come in from email is, why does the moon sometimes look super big in the sky when you look at it, and then a few hours later, it's super small on the same night in the sky? And I'm happy to tackle that, but if any of you all prefer to, feel free to speak up. So they're asking about the moon illusion.
Go for it, Amy.
Okay, I've been nominated. Okay, so a lot of people experience this when you see the moon near the horizon, either just rising or just setting. It seems like it's really huge. It is your brain playing tricks on you. You could hold your arm out and you could still cover up the moon with a finger in the same way when the moon is higher up in the sky. So it's not that it's actually bigger. I've heard, I have not had the nerve to test this in public, but I've heard that you can break the moon illusion by mooning the moon. Turn around, bend down, look through your knees at the moon. If anybody tries that, report back to us. Okay. So I am wondering from Mike and Doug if we are ready to switch to Mars or not. You all will have to let me know. And I'm going to check the Q&A. Oh, there's a question from somebody. Is there any place without a moon? So I think that's a question about, are there any planets without moons? So Mercury and Venus don't have moons. So yes. Okay, let's see what else we've got. Why does the moon look like it has holes? Those are craters from rocks from space hitting the moon's surface. All right. Doug and Mike, you have to let me know, are we ready to look at Mars or not? Okay, I think they're still working. So Dr. Sheila,
Well, I can comment a little bit more on the craters.
Okay, that'd be great. And then I have a question for you that came in by email earlier, but let's hear about the craters more.
Yeah, so if you think about it a little bit, you might be wondering, well, why are there so many craters on the moon from rocks hitting the moon and not just as many craters on the Earth? Because rocks must hit the Earth too, right? I mean, a lot of us have seen meteors and we know rocks come in and hit the Earth. And the real difference is that a lot of rocks have hit the Earth and a lot of rocks have made craters on the Earth, but they've gotten smoothed over. So those areas in between the craters on the moon that were smooth are called mare, from the Latin for seas. And they actually were formed from seas of molten rock that smoothed over those areas where if there were any craters, they got covered over by a layer of liquid. But on the Earth, the whole planet has been covered over by volcanism with lava. Many times over, any craters have been smoothed over by molten rock. And that's because the Earth is volcanically active, whereas the moon is not.
Great, thank you. We had a planet question that came in from email by Indra, who has just turned 4 years old and has a question about planet Uranus. Indra knows that Uranus was knocked over on its side and wants to know how that could have happened if Uranus is supposed to be this gas or ice giant. If it's not completely solid all the way through, how could something have knocked it over? And I wondered if you could help us understand that.
Yeah, sure. Just to make sure the whole audience is caught up to speed to our 4-year-old Indra, let's just make sure everybody knows that early on in the solar system, there were a lot more planets than there are now, and they were all crashing into each other as the solar system was forming. And so it was quite common for there to be collisions. And in fact, we expect that our own moon, the moon of the Earth, was formed from the debris of a planetary collision between the Earth and another early planet that is now gone. So most of those planets didn't survive. And Uranus in particular was hit by a small planet, much smaller. It'd be kind of like an adult being hit by a small dog. So the planet Uranus got hit and it tipped over, and it tipped over almost completely on its side. Now, what Indra is asking is, how could it get tipped over if it's gas? Like, you couldn't tip over a cloud, right? Like, that doesn't make sense. Wouldn't it have to be a solid object? So let me first say that Uranus actually, although it's called a gas and ice giant, it is actually a mostly solid object. So if you actually look at the interior of Uranus, it's not like a cloud. It is actually, there's a core that has rock and ice, and then there's a mantle that has a lot of ice, and then there's a relatively thin layer of atmosphere, not as thin as the Earth's atmosphere, but it's relatively thin compared to the solid object. That said, even if it weren't, even if it were like Jupiter and had almost no solid core, we don't even know whether Jupiter actually has a solid core or not. And even so, it could have been tipped over. And the reason is that it really behaves like a single object for a couple of reasons. One is it's held together tightly by its own gravity. A cloud that's in our upper atmosphere doesn't have any appreciable amount of gravity holding it together, but a planet is held together strongly. Another thing is it's spinning, which means it has a clear sense of up and down. So it's possible to tip something that has an up and down, and that includes the atmosphere as well as the ice and rock layers. They're all spinning together. And they can't spin differently because there's friction between them. So they really have to function as one solid object. Now, of course, if you get something the size of a small dog knocking into an adult human, it could still tip over, especially if it came in fast. And if there's a gas layer, it probably did plow right through the gas and splash it all over the place and break up some of the ice mantle, maybe even some of the rock. But because that tipped over thing would still remember how it was spinning, and because it still has gravity, it would become round again in its new tipped over position.
Great, thank you. And thank you, Indra, for that really interesting question.
Yeah, that was fantastic.
Yeah, so while we're on planets, I want to check in with our astronomers. Mike and Doug, do we have a view of Mars? Is our only evening planet right now, and I know we're contending with some clouds and possibly sketchy internet.
I have one. Mike, are you?
No, I only have a previously captured version. So
Previously captured version. We can. Doug, do you have a live version of Mars? Or we?
I'll show you the live version, and then I think then you can appreciate Mike's.
Okay. Okay, so we're going to see
All right.
real Mars in real time. And remember, you all can walk outside and see Mars with your own eyes. It is visible to the unaided eye.
So can you see that now?
We see your screen sharing.
There, you should see a red dot on my screen.
We do. Is that Mars?
Yes. So Mars, in October, Mars was extremely close to the Earth. And so it was at a point in its orbit that we call opposition. And so at opposition, you've got Earth right in between the sun and Mars. And so Mars shines brightest and generally is closest at that point. So you can actually see a lot more detail on the planet. Since then, our two planets have split apart in their orbits and are very far from one another. And so now Mars just only appears to be a lone, almost like a red star in the sky.
So, and Doug, are you able to get a little bit closer to your microphone? You're a little bit quiet.
Oh, sorry about that. How about that?
Oh, that's fantastic. Yes.
Yes. So anyway, again, our two planets have actually moved far apart, very far apart. They're already quite far apart as it is, but they've now moved far apart in their orbits, and so Mars just looks like a tiny little dot. You know, for most people getting telescopes, I will say that this is where they get disappointed when they get their telescopes out. They see Mars in the sky, they point their telescopes, and all they get is like a small little red dot or even a red star. And generally, the best time to observe planets is at the point where I mentioned before, is at opposition, the point where the Earth is actually right between the sun and the planet. That's generally when it shines brightest and you can see the most detail. So that's the case we have tonight. We are far away, we're not at opposition, and so it looks like a small star. For those of you who have telescopes, have always wondered, well, why can't I see anything better? Well, it's not your telescope and it's not you. It's just that you're now very far apart in the night sky and with respect to where Mars is.
Yeah, Doug, when we do public skywatching events, which are on hold right now, but we hope to bring them back soon, our free public monthly skywatching events, I feel like whenever we show Mars through a telescope, I always say, okay, everybody, adjust your expectations. It's going to look like a pink ball.
Yeah, exactly. Yeah.
And it's so far away right now, as I recall, it's currently about 15 light minutes away. So when we communicate with the Perseverance rover, it's a 15-minute one-way trip for those signals to get sent from Earth to Mars.
Exactly.
And Mike, I hear that you may have a previously taken image of Mars.
So I'm going to stop my share and take it away, Mike.
So, all right. So this is a capture that, as Doug mentioned, opposition between the planets was back in October of 2000. And this video was captured then. So I'll just go ahead and hit play. And even with a very steady, solid mount, and so, you know, and the telescope tracking very well, you can still see how much that Mars is actually moving around and kind of shaking. you can almost see it. Again, it's not twinkling, but what's causing that again is the refraction in the Earth, in the Earth's atmosphere. So what I wound up doing is collecting, it's about 30 some odd seconds of this video that I took, but I wound up taking all that because I did it at somewhere about 60 frames per second. So 60 times 30, I was able to then take all of those pictures, that video, individually look at them, and then let's get this to open. Okay, it's over. So when I, in essence, stacked all those images and played around with it, that's what I got. So you can actually start to, even though the video didn't show it, each of those frames, when you strip them apart and then try to stack them together and perfectly overlay them, it eliminated a lot of that waviness and shakiness, and that's what you get when you process it that way. So, and you know, I maybe took a little bit of extra liberties in trying to highlight some of the you know, the differences between you know, just the regular reddish areas and then what we can see in terms of what they used to think was oceans on Mars and canals, but that's just the various different geological features of Mars.
Okay, thank you for that. I think you may have just answered a question that was asking about its surface features. So thank you for that.
Yep.
So I have a question for you all. I know that our plan was you were going to show some things in Orion. Will that be a possibility? Should I get Stellarium fired up to get people prepped, or? I think we may have lost Mike there. Okay. So how about you, Doug? See if we've got him. Okay, well, I'll get ready to share Stellarium, but I wanted to check in with Dr. Sheila. Is there anything that you wanted to say about Mars or any planets before we move on?
Well, I just wanted to point out, and Mike and Doug, if they unfreeze, know more about this than I do because they're NASA ambassadors, but we do have a rover on Mars, Perseverance, and one of the main goals of that rover is to look for evidence of past life. There has been a fascination with the possibility of life on Mars for a very long time, not because it's currently habitable. Currently, it has no atmosphere and no oceans, and it's really not a very nice place to live, contrary to what some billionaires might want to tell you. But in spite of that, it did once probably have oceans and an atmosphere and was probably a pretty temperate place temperature-wise. And so there is reason to believe it could have supported life, and a lot of interest in seeing whether there are clues to that former epoch, or possibly even surviving little fossils or little microbes, because we know there are extremophiles here on Earth. So maybe once life has evolved, maybe it could survive or even spread from planet to planet through meteor impacts and rocks. That's called panspermia.
Great, thank you. And I know, Sheila, that you have some things to share with us about Orion. So I will go ahead and share my screen to show people what we're talking about in the sky. So if you were here at the beginning at 8 o'clock Eastern time, you already saw views of the moon. We saw craters. You saw views of Mars. Next, we're going to, if the sky cooperates and if all the technology cooperates, we're going to look at some things in the vicinity of Orion, this constellation here. And I'll show it to you better in just a moment. And then Sheila, I know you have some things to share with us as well. So I'm going to get us a little bit zoomed in here. Let's go a little bit closer. So we've got kind of like a west-southwest view. Let's maybe get a little bit. And this is the sky as it looks like, well, pretty much, let me make it right now. So 8:35 p.m. in the Triangle area in North Carolina. And so you still are seeing a little bit of glow from where the sun set. And we still have winter constellations in the sky, even though we are well into spring, astronomically speaking. But if you go out early in the evening and you look towards the west where things are going to be setting before too much longer, you still see winter constellations. And one of the prominent winter constellations is Orion. The easiest part of Orion to find is his belt. 3 bright stars right in a row. So see if you can find those 3 bright stars right in a row. Stellarium does not have labels on any of them, but see if you can find kind of a line of stars. And it's a horizontal line right now, the way things are oriented. So I'm going to circle that general area. So that's Orion's belt. If you're going to try to picture Orion, you might imagine a hunter. Here's the belt. He's got a sword hanging from the belt. We'll talk about that in a minute. He's got 2 shoulders. That bright one is Betelgeuse. And then he's got 2 knees or feet, and the bright one is Rigel, maybe some sort of bearskin or shield that he's holding up. He's got a tiny head and then some sort of club up here. So let's see if we can get a picture of Orion. You do not have to picture Orion this way. There is nothing official about how you play connect the dots with the stars. There's nothing official about the artwork. The only thing official about Orion is his name. Astronomers around the world have agreed to call this part of the sky Orion, and the boundaries of Orion. So everything within these outlines is part of Orion, the hunter. And by the way, this is arbitrary. Constellations are made up human inventions. They are not natural groupings of stars. It's the human brain looking at the sky and saying, yeah, I'm going to picture a hunter here. And by the way, not everybody has pictured a hunter in that part of the sky. What you picture tends to be what's important to you and what's familiar to you in your own culture. So there are some Native Americans, for example, who have seen things like canoes in the sky. It just depends. Okay, so in this area, kind of the sword hanging from the belt, there are, I'm going to cheat a little bit. I'm going to see if I can keep us up a little bit later. And this will make the sky a little bit darker. I'm going to freeze here for a second. And within this area is a place where stars are being born. It's called the Orion Nebula, or M42. And we might have a little bit more to tell you about that. I'm going to stop sharing my screen. And then Mike and Doug, a heads up that in a moment we'll ask you to show us things in Orion if you're able to, but maybe Sheila, do you want to start? I know you have an image to show us. I don't know if you want to give us some background first.
Sure, I can do that. All right, can you see my screen?
Yes.
So here's some houses, and here's the Orion constellation, and here's also the Orion constellation. And this view, or the background of this view, is what you can see with your eyes, of course, with the lines drawn in. But the colors that are flashing in here and the orange scale that is shown here are what you would see if your eyes could see in millimeter waves, or the infrared. So millimeter waves on the left are showing you the dense gas. This is the dense gas out of which stars are born. So you can see that the Orion constellation is a hot spot for new stars to be born. You can also see that in the infrared, because the infrared glows when there's warm dust, and dust is mixed in. This is the classic stardust, but we just call it dust. Dust is mixed into gas, and when it gets warm, it glows in the infrared. And you can see again that Orion is full of such hot spots. One of the hot spots and one of the sites of dense gas is where my cursor is. I hope you can see the little arrow. That is the dagger of Orion. And the dagger of Orion is the M42 nebula, which we're going to try to look at. And then there's also another hotspot up here, which I believe is near where you can see the Horsehead Nebula. I'm not sure if we're going to be able to go there tonight. So that's just a fascinating view of how you could see the sky if you weren't limited to visible wavelengths. Now, zooming in, so again, we're not going to see the Horsehead Nebula tonight, but that's what it looks like. It's gorgeous. That red light, which is visible to your human eyes, if you had a strong enough telescope to see it, is coming from the inside of a region, a bubble of ionized gas. And that has been ionized by the hottest and most massive young stars. And over here, the Orion Nebula, you can actually see the edges of a similar bubble. This one is in false color. It should actually also be red if it were in true color. And you can see the bright stars in the middle of the bubble that are creating that ionized gas. So this is not in a strange wavelength that you can't see with your eyes. And if you have a good enough telescope, you should be able to see, especially that red color of the nebula.
Thank you. And y'all, those of you watching, if you're thinking of questions, please pop those into the Q&A if you're on Zoom, or email us ncscifest@unc.edu if you're watching on YouTube. Doug and Mike, are you able to show us anything in Orion? What's the situation over there?
All right, so I'll interject first. So we had talked about Beetlejuice at first, so I went ahead and popped over to Beetlejuice. I'm sure Mike is getting over to Orion Nebula. I will say, Sheila, I do have a canned photograph of the Horsehead, so that we can take a look at after Mike is done talking about the nebula. But I'm going to share my screen real quick so we can actually see Beetlejuice. So Beetlejuice, Beetlejuice, Beetlejuice. And there it is. All right, can you guys see that? Looks a lot like Mars, doesn't it?
It does.
I promise you, I'm not looking at the same area of the sky. That is Beetlejuice. It is a red supergiant, one of the few remaining red supergiants that we have in the night sky. You know, if it was actually placed in the middle of our solar system, it would actually extend all the way out past Jupiter. So it's a really massive star, so that's how Beetlejuice looks tonight. And so that's not a lot to say. It's just a kind of a red dot in the sky at this point. So I'll defer to Mike. Mike, are you ready with Orion Nebula, or do you want to show your earlier image? Okay, all right. I'm going to stop sharing.
So just to confirm, you guys can hear me. I was having some connectivity problems.
Yeah,
we do hear you. Yes.
Okay.
Thank you.
Great. So I am going to share.
Wait, before we leave Beetlejuice, I think we do have to say, a lot of you may have heard about a year ago, there was a lot of talk in the news about Beetlejuice because it is a very close by red supergiant, and it is within plus or minus, well, definitely plus because it would have already happened, a few 100,000 years of exploding. It is already 10 million years old. It is a very massive star, so it has a short lifetime compared to our sun, and it's ready to blow. And they saw it about a year ago. They saw it suddenly dim quite a bit, and so there's a lot of speculation. Oh, is it about to blow? If it has blown, we might not know because light takes a finite time to travel, but you know, plus or minus hundreds of thousands of years is a big error bar. So don't necessarily expect it to go in your own lifetime, but it is very cool.
And thank you. We have a question. Is the star we're talking about the really big dot? So we're seeing the red arrow of the cursor, and then we're seeing a big dot, and there's just a question. Yes.
I just put my cursor underneath the underneath it, so you should be able to see it.
Excellent. Thank you for that clarification.
And it's Orion's shoulder.
Yeah.
Yes. Yes.
So,
and it noticeably looks reddish.
I like to think of it as being in the armpit.
Armpit of the giant.
All right. I'll stop now and I'll let Mike share his screen. All right.
all right. So I think I am sharing.
Yeah.
We see your sort of setup screen.
We see a
Yep.
Bluetooth screen.
Thanks. I'm just trying to get this. All right. Trying to drag the video over. There we go. So this is a video that I took really probably Wednesday night, Thursday night of the Orion Nebula. So I will go ahead and get that kicked off. Apologies. Let's play. So what we're doing here is we're looking at just a single shot of the Orion Nebula, and making sure that it's now was in frame. And now what I'm telling the camera to do, and also the computer, is to now do a longer exposure. I'm exposing for about 10 seconds, and this is one of them. And then what it's going to do is every 10 seconds, it's going to get another picture, and it's going to lay it on top of it. And what it's doing is the computer is basically adding up all those pixels. And so eventually you start to get a much nicer and a cleaner image of it. So, and we can also start to play around with the different settings, if you will, of, how the, what kind of color we want to focus on, what kind of gain, or how much the exposure we want to run. So there's, while you're taking these live streams or live views, you can really start to augment and try and focus in on certain parts of the nebula. I will say, if you try to look at this with the naked eye, you really aren't going to see any color. You'll be able to see kind of that gull shape right there. And all I'm doing here is applying what's called a dark to help counteract any noise that comes through the picture. But now I'm just starting to, in essence, something called stretching the histogram of the particular photograph or the image, just trying to tease out whatever kind of detail you want. And you can, as I'm playing with the different colors, accentuating, I want more of the red channel coming in through the color camera, or the blue or the green or whatever. So I can play around with certain settings just to try and get as much detail as possible from what we're looking at. You can almost see this, it almost looks three-dimensional, like we've kind of looking inside of a bubble. And that's really almost what we are looking at. You've got these really bright stars right there called the trapezium. And then I think in just a minute, I kind of try and focus only on the trapezium. But the radiation from these stars is kind of like basically pushing this gas out and pushing it away. And it's basically a stellar nursery. It's where planets and stars are being born right now, 1,400 light years away. So we're just kind of playing with the different settings here. And I think pretty soon you'll see I kind of really kind of tone down the nebula and try and look at the, just the, specifically the, there we go. Try and get down to those, just those stars there in the trapezium, what it's called. You can almost make those out right there. Just, let's get those four really, really, really bright stars that are really, I guess, causing all that radiation and causing this nebula to glow.
All right, thank you. Thank you, Mike. Remember, you all, if you have questions on Zoom, put them into the Q&A. If you're watching on YouTube, you can email us, ncscifest@unc.edu. So we've got about 12 minutes left. We'll need to save a few questions right before 9. Save a few minutes for questions right before 9. So I'm wondering, Mike and Doug, do you have a preference? Do you want to get ready to show M3 next, or M81 and M82? And I'll do Stellarium to help people find those.
Let me just interject real quick and share my screen with the Horsehead Nebula on it.
Yes, please.
So I'll just do that very quickly.
And I prefer the galaxies, but that's just me.
Okay.
Yeah. So yeah, we can definitely go right over to the galaxy. So if you'll see right here where I'm kind of circling around here, this is actually the Horsehead. You can kind of see this little red area here. Let me see if I can just kind of make that bigger. That's actually where the Horsehead is right there. And there's all that red gas that Sheila was talking about a little earlier. Now this picture is a bit blown out because of this one particular star. It's kind of blowing out the photograph. And probably the next time I take this, I'm going to move this star out of the field of view I was trying to also grab this other nebula here that you can see my cursor going around called the Flame Nebula. And as Sheila mentioned earlier, this is a great area for nebulosity and exploring nebulae and stellar nurseries. It's just so much fun to explore Orion. I've been doing this hobby for about 22 years now, and I never get bored with it. It's such an incredible thing. So anyway, yeah. So this is really kind of that other area of gas and thermal activity, new birth, and so forth that Sheila talked about a little bit earlier. So, okay, that's all I have, and we'll go right over to the. If you want, I can show sort of my my pieces of the galaxies if you want, Mike, and then you can show yours, or what do you want to do?
Yeah, I can share my views again. I'm clouded out, so.
And
Okay.
while they're switching over to the galaxies, I just want to add, since Orion is so much fun to look at and so easy to find in the sky, you're going to be able to see just with your own naked eye. You won't need binoculars, you won't need a telescope, that the dagger is fuzzy. And so from now on, whenever you notice that the dagger of Orion is fuzzy, realize that you are looking at that bubble of ionized gas around the trapezium. You are looking at a place where stars have just been born and some stars are still being born.
Okay. So we're gonna actually look at a really interesting. Mike's got some great shots of this particular area. I will go ahead and share mine. This is Bode's Galaxy, and this is another little galaxy, M82 up here, which is called the Cigar Galaxy, colloquially. But what's interesting is that this galaxy, Bode Galaxy, which is M81, is actually it's causing this galaxy here to kind of stretch out and split apart. And the core of this galaxy is experiencing a lot of upheaval in it. There's about 197 star clusters that are over 200 solar masses, besides the black hole that's at the center. And the other thing that's really interesting about this little cigar-shaped galaxy is that it has an intermediary-sized black hole, which, unlike most galaxies, we see galaxies that have, supermassive black holes. But this one's considered more of an intermediary black hole. And Sheila, you're going to have to correct me if I'm wrong. I believe that's a little bit greater than 20 solar masses, but I unfortunately on that statistic I'm a little wanting for knowledge. So, but
yeah, it's more than a little. It's more than 10,000 solar masses.
Well, good. Well, see, that's more than 20. But yeah, exactly. Perfect. But the thing is that there is, again, we have star clusters that are greater than 200 solar masses, about 197 of them, and then you've got this intermediary sized black hole. There's a lot of energy flowing. There's a central rift. We'll go to that in just a second. And I'm going to just quickly. There's
well, let me Galaxy. Just say there's also a supermassive black hole, which is more than 20 million solar masses. Mm-hmm. So that is not considered as special, because for a galaxy like that to have a supermassive black hole is not surprising. Actually, it's the smaller black hole, the one that's maybe 100 times smaller, that is actually the one you mentioned that people are excited about, because a middle-sized black hole, it turns out, is harder to find in the universe, and it represents an evolutionary connection that astronomers are trying to understand between the smallest black holes and the supermassive ones.
Very cool. That's cool. All right, I'll stop and then let Mike go ahead and share his, and then I've got another one of M81 that I think will be good. So I've stopped share.
Yep. So yeah, And again, these were this was our backup. We captured a lot of these images last week, knowing that we had some potential weather. So this is the same thing that we've been doing, which is called electronically assisted astronomy, where we're doing the observations. It's just we're using a camera to make the observations. We're not necessarily doing it to take beautiful pictures. These are unprocessed, usually about 10 minutes or so worth of captures. So this is that of the larger of the two galaxies, M81, Bode's galaxy, and they originally thought it was a nebula. But what I love about this is that, you know, if you've got nice dark skies and the time to look at it, you know, you start to really see that spiral structure in there. I think you've got this nice, I think that's called a barred spiral galaxy, if I'm not mistaken. I think I see a bar in there. I could be wrong. But, you know, it just blows me away when you can start to see these spiral arms and you see the dust and nebulosity within those arms. So that's the big one, one M50, M81. Then, and they're really close. They could almost fit in my field of view of the camera, but just outside of it. So I can't really get both of them. And here's M82. And you can see how distorted this one is compared to M81. And obviously it's been gravitationally distorted. And I think it is called a star, now I can't remember the name, but a starburst galaxy. If I recall correctly, there is 4 times as much star formation going on in that galaxy than there is right now in the Milky Way. And it is thought that the reason because of that is the gravitational interaction and the tidal forces that M81 imparted on this kind of caused a lot of that dust and gas to start spinning around and coalescing and creating more stellar nurseries.
Yeah. Hey, so if I could interject my my view of that real quick, Mike, that'd be great.
Yeah, let's see it. And then I know Sheila's got an image, and then that's going to take us almost to 9. We do have some questions. Okay. And then we'll officially end at 9, but we will stay on for those who have more questions and want to see more.
So let me just share this. I kind of really like zoomed right in on that while we were out at Staunton River last week. And it looks like a split almost in the middle, but that's not a split. That's really a rift of gases that are actually flowing through the center of the galaxy. So it is there's a lot of energy being coming through this galaxy, and I guess being affected by Bode's Nebula. I think, Sheila, you have actually something that may describe this a little better, but just visually, I kind of pulled in here to see if I could see that rift, and I kind of pulled it apart there. Again, it's not split apart, but there is a river of gas and dust. It's actually flowing over the, it looks like over the top of it. So I'm going to stop now and let Sheila show her stuff. Go ahead, Sheila.
Yeah, so the important thing is the dust. You zeroed in on it. Of course, gas and dust are always mixed together, but the dust is what makes it look so dark, as if there were a hole in the middle. It's not a hole, it's just that it's covered over, so it's dark. But so here's the same view, just photo reversed. So it's like a photo negative. Here's the big galaxy, Bode's galaxy, and the little one is the Cigar. And you might also notice there's another third galaxy down in the lower left. Can you see that? Okay, so those are what you would see with your eyes through a telescope, except of course you would see white on black instead of black on white. But now I'm going to show you what you can see if you could see in radio waves, if your eyes could see radio waves. And so now you can see that we don't have to speculate that these galaxies are interacting with each other, because they are completely connected in radio waves. And why is that? Well, the radio waves are detecting the gas. What we see with our eyes is bright stars, but the radio waves detect hydrogen gas that is all around these galaxies to much greater distances. And you can see they're all entangled with each other and pulling out arms and tails. So it's actually a 3-way interaction. And not only that, but there's these little things. I don't know if you can see my cursor, but there's little things here and here And here, these little galaxies are believed to be what's called tidal dwarf galaxies, which means they didn't even exist before these galaxies started interacting with each other. They were spawned by the interaction. So it's a beautiful system. If we could see our sky in all wavelengths, it would be amazing.
Wow, thank you, Sheila. We are just about out of time, so I want to pose one question before we officially end, but then we'll keep going for those who want to geek out with us longer. You were mentioning the mass of black holes. Somebody wants to know how wide was the black hole?
How wide? Well, so black holes are technically singularities, which means technically they have no size, but we do sometimes talk about their size in terms of the size of the region within which light cannot escape. And so a very, very massive black hole, like you might have heard, it was a big deal maybe a year or two ago, I can't remember exactly, the first time the so-called event horizon of a black hole was ever imaged by the Event Horizon Telescope. That was also a supermassive black hole. And its entire dark region within which light cannot escape was kind of the same size as our solar system. And that is just to tell you that the size that you might see of like literally being black of the black hole. But you know, the black hole itself is a point of space-time. It's a singularity. So that dark horizon isn't the black hole exactly. It's just how we could define its size.
Great, thank you. Thank you for that question. So we're gonna hang on for another 30 minutes for anybody who wants to ask more questions. We have a couple that have come in that we haven't had time for yet, or we'll look at more things if we can. Anybody who needs to leave, thank you so much for joining us. Thank you, Dr. Sheila. Thank you, Doug and Mike, for joining us. Thank you, everybody, for participating and for your curiosity and questions. If you want to look for more Science Festival events, North Carolina Science Festival events, check out ncscifest.org, and you'll find more statewide Star Party events happening tomorrow and other science events throughout the month of April. So, all right. With that, we will hang on for those who want to hang with us. So let me pose a question that came in a while ago from the Q&A while Doug and Mike get ready for whatever they might want to show us next. The question is actually about the moon. I'm happy to handle it, but I thought, Dr. Sheila, maybe you would want to get this one. Stephanie has always wondered why the moon is sometimes out in the daytime.
I feel like I've done way more of the talking than you have, so why don't you take that one?
Oh, okay. Well, sometimes, so here's the deal on the moon. So what the moon looks like in terms of its phase, like whether it's just a thin crescent or it's fully lit or somewhere in between, when you see it and the time are all related to each other. So phase, time, location are all related. And it all has to do with the moon's orbit around Earth. That's what creates the phases. So full moon, it's fully illuminated by the sun. Full moon is opposite the sun in the sky. So if something is opposite the moon in the sky, excuse me, something is opposite the sun in the sky, that means you're not going to see it in the daytime. So full moon, by definition, is up at night, all night, only at night. New moon, a couple weeks later, new moon is with the sun in the sky. You're not going to see a new moon because it's the backside of the moon that's getting lit up by the sun. A new moon is with the sun, so it by definition is up in the day, all day, only in the day. Any other moon phase, the moon will be up partly in the day, partly at night. So the moon phase right now is waxing crescent. It actually rose this afternoon. You might have noticed it if your sky was clear before the sun set. It was up in the daytime, and it will continue to be above the horizon through the evening hours. It's going to set roughly at midnight. So I hopefully didn't do too much astronomical dyslexia in that explanation saying moon when I meant sun or vice versa. All right. Doug and Mike, do you all want to show us something else, either a live view through your telescope or a previously recorded view?
Okay, so I can go to a previously recorded view. So one of the things that we didn't get a chance to talk to in the main program was this globular cluster, and I'm going to share my screen in just a second.
Is this M3?
This is M3, yes.
And at some point when we have a transition, I can pop back into Stellarium and show people where M81
Yeah,
is.
you want to do that first, Amy, and
Yeah.
then we'll show that. Yeah, that's a great idea.
Yeah, okay, so I will share my screen again. So this is going to give you all kind of an overview of what we're looking at. Okay, so before we were looking at Orion. Let's see if I can get let's get back. Let's try to find the horizon again. There we go. And remember, if you want to play with Stellarium yourself, you can download it from stellarium.org. Okay, so let's spin over to more the north, kind of northeast, because what I want to show you is we're going to do a little star hopping here. So we're going to find the Big Dipper. Let me zoom in just a little bit more here. Okay, so everybody look at your screen right now. See if you can spot 7 bright stars that if we played Connect the Dots, we might get something that looks like a Big Dipper or a soup spoon, maybe. And it's kind of dumping the water out of the bowl of the dipper. So you're looking for 3 stars in the handle, 4 stars in the bowl. It's fairly high kind of here in the northeast. And somehow it got to be 9:30. I'm not sure how that happened. Let's change back to the real time. Okay, there we go. So here's the sky as it looks like right now. So the Big Dipper is in here. It's fairly high above the northeastern horizon. We've got 1, 2, 3 stars in the handle, 1, 2, 3, 4 stars in the bowl. And the Big Dipper is not an official constellation. It's a pattern within a constellation. And I'll show you the outline and the picture we have for it. I think it looks more like an anteater, but somebody thought it looked like a bear. It's a very strange bear with a very long tail. So the Big Dipper is part of Ursa Major, the Big Bear. And by the way, the Big Dipper is a great pattern to know because it can help you find so many other things in the sky. If you go from the side of the Big Dipper here, start at the bottom of the bowl Merak, go through Doobie, keep going, you will get to Polaris, which is the North Star. And if I turn around a little bit, you'll actually see how this star is right over the northern horizon. And that's because this star just happens to be over Earth's North Pole. It's over our planet's axis of rotation. It acts like a pivot point in the sky. Okay, but going back to the Big Dipper here, you can use the side of the bowl to get to Polaris, the North Star, and thus find north. And by the way, you also get to the Little Dipper here. You might see that Polaris is the tip of the handle in the bowl. It's also part of the Little Bear, Ursa Minor, very cute bear. It's also got a strangely elongated tail. And then you can use the Big Dipper, not just to get to the North Star, but you can use the handle of the Big Dipper to get to one of the brightest stars in the sky. This is actually the brightest star of spring and summer. So you curve off the handle, you arc off the handle to Arcturus, which is part of a constellation called Boötes, the herdsman. And we've also got hanging out in this part of the sky, this star right here. I'm going to try to click on it, Corcoroli. It's part of Canis venatici, the hunting dogs, hanging out under the tail of Ursa Major there. And it's all kind of in this vicinity, the things that we were just looking at. So I'm going to use Stellarium's search feature to find M81 and M82, just know that it's close by. So M81 and M82 are kind of hanging out here on the bear's back. So those 2 galaxies that you were seeing in the same field of view, that's where they are. They're hanging out near Ursa Major, the Big Bear. And then we're next going to show you something called M3, and Mike and Doug and Sheila will tell you all about what this is. And it's hanging out in Canis venatici here, kind of between Corcoroli and Arcturus. And I'll leave you in suspense. I'm not going to zoom in because they will show you what those things are. So I will stop sharing.
All right.
And
great job, Amy.
Take it away.
All right. So I think you guys can you see my screen now?
Yes.
So this is M3. It's a globular cluster. and it's got about roughly 500,000 stars in it. It's very bright. It's actually, the core is blown out. I need to, probably the next time I take this shot is maybe try to underexpose the core a little bit so I can get some more of that detail, those detailed stars in there. But yeah, it's I took this out at Staunton River last week. It's just an amazing, just a beautiful object, and it's a really strong visual object. You don't have to have a special camera to see this. If you actually take Amy's pointing instructions and everything, you can easily find this in the night sky, and it's a real pleasure to look at. Yeah, so this again, it's M3. And Mike, I don't know if you are ready with your image or not, but it's one of the globular clusters. I will say it's called a globular cluster, and the reason why is actually Sir William Herschel actually named this. It's globular actually comes from the Latin word globus, and that just simply means sphere. If you think of our globe as a sphere, this is what globus comes from. And so it's just, and then it's a cluster. So it's basically, it's a spherical cluster of stars. And that's what a globular cluster is. We don't really know how they formed. Some speculation is that we may have already had another interaction with a galaxy sometime in our galactic past, and that these actually may be remnants of another galaxy. Others are saying that, hey, no, these formed very early on in our galaxy, and so the stars are very old. We know that they are low metal stars, so they are very, very old. But yeah, they're incredibly beautiful to look at. I sometimes think of them as like a diamond brooch. So you can also see that there are these really interesting tendrils of stars. These stars that appear to be along the same chain, and these are known as tendrils. And one of the greatest examples of this would be M3. I'm sorry, M13. And Mike may also have a picture of that. So I see Mike has grabbed the share there. So Mike, go right ahead.
Yeah, so this is what, again, in fact, I think same evening that we did. So we're capturing them. Yeah, so I tried to get this one exposed just right, but you can really start to detect the concentration or the density as you get into that globular cluster really starts to increase to the point where you really can't even make out in the center. It just looks like one big bright blob.
Cool.
But very cool things to observe. They're beautiful, especially when you've got different colors and different brightness stars all intermixed.
Thank you for these lovely images.
Thanks.
We have a question that's come in about stars. I don't know who wants to take this. Maybe Sheila. It came in from email. Somebody wants to know a little bit more detail about how is a star born. So we were showing places where stars were being born in the Orion Nebula. How is a star born?
So I'll try to give you the short version. So what's surprising about how stars are born is that they are born out of cold material. And that is because if gas is hot, then it's trying to expand. And what we need is for something to condense and become very dense so that it can become a star. So dense cold gas, which is what's in that Horsehead Nebula, by the way. The Horsehead itself, not the red glow around it, but the Horsehead itself is a piece of dense gas, and you're seeing its shadow against that red glow. So those bits of very dense gas are where stars are about to be born. And there's a transition from having that very dense gas and having it actually start to not have enough heat or enough motion internally or enough rotation to keep it from collapsing. So then it will start to collapse and form a star, but then there's going to be a transition where at some point it will collapse so much and become so dense that now the star is going to turn on. And when the star starts to turn on, then you get thermonuclear fusion and you have now a full-fledged star, now that star is going to generate a lot of radiation, of course, but also winds and outflows, and it actually drives material away. And so that transition is what then carves out the bubbles that you see. And some of that carving out is because of actual mechanical force, actual winds from the star. And some of it is because the gas has been ionized, so it's still there, but it's invisible because it becomes transparent when it's ionized. So that's kind of in a nutshell the star formation process. Of course, there's a lot more details to it.
Thank you. Thank you for that. What next? Mike and Doug, do you have something for us, or should I fire more questions at you all from the Q&A? We have some interesting ones coming in.
Yeah.
Go ahead. Yeah, go ahead, Mike. Yeah.
No, I was going to say, I've got one that I wanted to share of, again, kind of preparing for this event last week. Did a little playing around. I'm going to hop over here, pardon me. Get this shared. In just playing around, looking at different galaxies that are available in Ursa Major, started looking at what you could be seen, really just kind of, it's underneath the bowl, but the way that the bowl was, the way Ursa Major is or was at midnight, it's upside down. So it was above the bottom of the bowl, if you can figure that out. But just scanning around there, and I was looking at this particular galaxy, or that's the one that I was trying to find, and lo and behold, then came across this other one. Didn't even realize it was going to be in the same field of view, and to me, just was amazing to see. The different shapes, and you can start to see, a dust lane in here, some arms. And then what really took me by surprise were these really small galaxies down here in the bottom. And, when we started to look, I had to look these up to figure out what they were. And so it turns out this is a grouping of galaxies called Hickson 56. And it's a little hard to get the right measurements in terms of distance, but when I looked them up, or at least what they said was about 425 million light years. So to think that the light coming from those galaxies took 425 million years to reach us was really kind of, is humbling, grounding, and yet, awe-inspiring all at the same time. And then we've got some of the estimated distances of these other galaxies that were on my list to observe. But that's the beautiful thing about just going out in the night sky. You never know if you've never observed an object before, you don't know what you're going to get until you actually observe it. Doug, do you have anything to share? Want me to? I think you're on mute. Did have another, and one of my favorite galaxies. Just pull that one up, is the Whirlpool. Again, another one. This one's also in Ursa Major. Actually, it's not in Ursa Major. It's very close. It's right off of the tail of the bear. I think it's in Serpens. I can never remember my constellations. But I love looking at this galaxy. It is my favorite of all of them, to see that pinwheel look, see the dust, see the gas, and it is interacting with this other galaxy back there. These are not attached. This is an optical illusion of just this, dust lane. This smaller galaxy is about, I believe, 3 million light years behind this main one, but they have had, interactions in the past.
That's gorgeous. Thank you for that image.
And everything that I think Doug and I are showing you are basically, like I said, 10 minutes or so of captures, really, no post-processing afterwards. It's as we saw them. Obviously, we have the ability to tweak and start to, fine tune some of the details, but for the most part, we're not doing, this is as we saw them on our computer screens.
And I should mention, we did drop into the chat within Zoom. If you're watching this from Zoom, we put in the links to short YouTube videos that Doug and Mike made of their telescope setups, and just that show how they're doing their electronically assisted astronomy. So check those out; they're pretty cool. Somebody says they're watching this from their backyard. Awesome. Glad you're looking at the night sky. I'm gonna jump in with a random, it's not random question, but it's not related to what you were just talking about. But we have a question from Carolyn. Whoever wants to take this, it's a question about black holes and what happens when you get too close. So the question is, what happens to the things that are sucked inside a black hole? Do they just not exist anymore?
So we wish we knew. Actually, this is a subject that is at the forefront of modern physics and astrophysics and cosmology, because in order to understand what happens to things that fall into black holes, you have to understand, first of all, do they actually fall in? What actually happens at the event horizon? And I misspoke before, the dark region that we have imaged around that supermassive black hole isn't actually the event horizon. That's what's called the black hole shadow, which is slightly larger. But the actual event horizon, where light absolutely cannot escape no matter what, is potentially, according to general relativity, a point where nothing special would happen. According to general relativity, a person would just fall past that event horizon without actually noticing any change until they were torn apart by the tidal forces of the black hole. But according to quantum mechanics, that's not possible, because then all of the information that that person has would be lost inside the black hole. And according to quantum mechanics, you can't lose that information. And so reconciling quantum mechanics with general relativity is right at the forefront of modern physics. And there are a number of ideas for how to resolve these paradoxes. Some of them involve string theory, which I don't work on, so I won't pretend to try to explain it to you. But another idea that people have suggested is that maybe this is where general relativity breaks down, and that actually at this point where we've said, light can't come back out and the person goes in forever, that actually maybe that's not what happens. Maybe that's actually the end of space-time, and right there's a so-called firewall. And the firewall is where space-time ends and there's just a quantum firestorm of particle creation. Right now, we don't know, because reconciling quantum mechanics with general relativity, like I said, is where it's at for the research on black holes, as well as those two branches of physics.
All right, that turned out to be a pretty deep question. Thank you. We have 7 minutes left, and I'm wondering, Doug and Mike, is there anything else you want to show, telescope-wise? We do have one more question.
I have Iota Cancri, or Cancri, in the field of view, and it's a blue star and a gold star that are close to one another. I'm still working a little bit on the color balance for that. I'm not really seeing the gold, but you can tell the blue really well. So I'm going to share real quick. And then Mike, I don't know what if you've got, I know you've got quite a few, so I'll just go ahead and share this right now. And all right. So again, this is there. I don't know how well you can tell that on screen, but these are two different colored stars that's really a double star. If you look at it, in fact, even as I was looking at it in my telescope through my finder scope, you can only see one star. So you need a little bit wider aperture scope. So this is actually, we're looking through the main scope, and and now you can see they're actually quite far apart in the field of view. But if you were just looking at it with a very small telescope, you might only see one star. So this is an example of a double star, and they are different colors, which means they're burning different kinds of elements. And maybe Sheila would, I don't know if you'd like to speak to that, or
Sorry, I was just trying to answer a question in the chat. What's the question you want me to answer?
is that we have two different color stars. They're obviously burning. They are fusing different elements. We're seeing that that being shown out in the colors that they're expressing. So I don't know if you wanted to.
Oh,
to
very
comment
cool.
on that.
Yeah, no,
Yeah.
they're probably not fusing very different elements because all stars are pretty much mostly hydrogen and helium, although if one of them is much more massive, it may be, if it's further evolved, it may have multiple layers that are fusing different elements. Eventually, as stars evolve, they develop these onion layers, and in each layer, they're fusing different things. But on the main sequence, which is where we find stars through most of their lives in their color versus their brightness, on that sequence, those stars are all mainly fusing hydrogen, and their different colors are actually reflecting their different temperatures, where the more massive stars are hotter and the less massive stars are cooler.
Mm-hmm. Very good. Just adjusting that image right there so you can. There. We can definitely tell that there is somewhat of a maybe reddish or gold color there. Definitely this one on the right is blue. So let's see if I can. That's my neighbor's dog. She likes to come out and say hi to me.
Well, we've seen there's dogs in the sky. You know,
Exactly.
hunting dogs.
Canis Major, Canis Minor.
Minor. Yeah, there's lots of animals up there. So
Yep.
maybe the dog wants to commune.
Yeah, maybe.
Constellations.
So, all right. So that's that one, and then I have one more, and then Mike, you want to take it away, or do you have something you want to go ahead and share now?
No, I'm good. I'm having technical problems with the scope, but now it doesn't want to connect.
Okay, I understand. Okay, so I hopefully you can see my screen. I did take the liberty. There's another really cool object in Cancer, in the constellation Cancer, and that is this really. It looks like an arrow in a way, but this is what we call the beehive cluster, and it's kind of like an old-timey beehive. It was kind of the concentric rings going up to the top. You can think of these stars as the little bees trying to go into the hive. But this is called the beehive cluster, and there are a lot of open. This is an example of an open cluster versus a globular cluster. And what's interesting about a lot of open clusters, they do have a tendency to make shapes, or what we call asterisms. The asterisms seem to form something. There's one called the coat hanger, another one, again, the beehive cluster. There's the owl. There's quite a few different open clusters, and again, like I said, a lot of them do sometimes have shapes, and so this is one of them. It's an easy find in a small telescope.
And our own sun was probably born in an open cluster like this.
So
I will say that honestly, I think the beehive looks most amazing in a pair of binoculars.
Yeah,
it's hard to get the whole beehive in a telescope.
Yeah, and Mike, you were out there. I was trying to capture this, and it was really difficult to get the entire cluster. I kind of opted for that core piece that everyone recognizes, but this is, as Mike said, this is a much larger cluster, and it's really pretty to look at night. I realize that this kind of looks like, white dots against a black background, but it is really when you're actually experiencing it yourself. It's a lot more breathtaking. Part of what we're trying to do with, of course, showing you these images and everything is kind of to inspire those of you who are still on the call to go out and really make this an experiential event for yourself, that you can go out and easily find these objects. And Amy has done a great job of showing you where they're at in the night sky. And if you'll pick up Stellarium, you'll be able to kind of plan your session when you want to go out at night. Go and find those things that are bright. And as Mike said, just with a pair of 10 by 50 binoculars, which you can, easily get from Dick's Sporting or a sporting goods store in the area. You can really begin your quest for astronomy right there.
And I'll put in a plug for you all. Mike and Doug are members of the Raleigh Astronomy Club. Those of you in the Raleigh area, there's also a Chapel Hill Astronomy Club called Chaos, Chapel Hill Astronomical and Observational Society. And those can be great communities if you are wanting to get involved in an amateur astronomy hobby. And of course, you all are always welcome to come visit us at Moorhead Planetarium and Science Center. We are open to the public on weekends right now. Okay,
and I also want to say that you don't have to have a lot of money for equipment to enjoy the night sky. If you have ever seen the Pleiades, which might be, I think, just ending its time in the sky now, I think it's sort of October to April object, but the Pleiades is this fuzzy little thing in the sky that you can see with your naked eye. That is an open cluster, and the fuzz is a little bit of gas left over from the birth of those stars. So it's actually a very young open cluster, and it's beautiful. You can see it with the naked eye.
And I did want to mention, while you mentioned the Pleiades, if there's anybody watching who lives in the city of Durham, you might know that your city has a nickname, the Bull City. There is a bull in the sky. We saw it, the constellation Taurus, the bull, the moon, and Mars are hanging out in Taurus right now. That is also the constellation that the Pleiades star cluster is part of. And that star cluster is represented on your city flag. If you live in Durham, look at your city flag sometime. That is a representation of the Pleiades. Great choice for the flag because Pleiades cluster within Taurus the bull. Durham is the bull city. And you can see that cluster with your unaided eye. Probably if you run outside right now, if it's clear. It's getting pretty low in the west, but it's still out. We are out of time, and I know we still had some kind of last minute questions come in, but thank you so much, everyone, for joining us. Thank you so much, Sheila Kannappan and Doug Lively and Mike Keefe, and also thanks to my colleagues, Eric and Nick, who are running technical issues. And any last thing you want anybody to know before we sign off?
Just enjoy the clear skies, clear dark skies.
Yes.
Exactly.
Thank you, everyone. And thank yous are starting to come in through the chat for those watching on Zoom. So we hope to see you all out under the night sky sometime soon. So good night, everybody. Thanks for joining us.
Good night.
Good night. Goodbye.
Bye-bye.
Clear skies.